So we learned about some use cases where it would be nice to access the web application even though we have no internet connection. And for that we can use the Cache API. Now here's an important thing. When working with web applications, there actually are multiple possible caches to work with. The server can cache some resources, but these still need to be sent over the wire, so they disqualify for offline access. The browser also manages its own cache, totally without you telling it to do so. This is the cache we disabled in the first course module. Now, disk cache managed by the browser has one big disadvantage. It's managed by the browser, you can't rely on it, you can't explicitly tell it which assets to cache and which not to cache. So you as a developer have no control over it, or only a very limited amount, and you can't rely on these files being there when you need them. That's where the Cache API steps in. A separate cache storage, also living in the browser, but managed by you as a developer. This cache holds simple key value pairs, where the key are the HTTP requests you want to send. So to put it in a simplified picture, simply the URL you're trying to reach, though it really is the complete request. And the value is the response you got back. So of course you need to have made that request successfully at least one time so that you got the response you actually want to display. Otherwise you can't cache it. You can't cache what's not there. But once you got that response one time, you can store it on the key, so on that request you sent, and then fetch it later on when you need to send that same request again but have no internet connection. And that simply is how the Cache API works. You store key value pairs, request and response. Now the Cache API can be accessed from both service workers and your ordinary JavaScript on your pages. So you can access it not only from service workers, but also from your day-to-day JavaScript running in your pages loaded through your HTML pages. That's important, and we will actually use both approaches of accessing the cache, and you will learn when which approach makes sense. So being able to access it from the service worker is powerful though, because keep in mind, the service worker runs in the background. You register it and it keeps on running. So normal JavaScript only wouldn't do the trick, because where does this come from? Right, it's loaded via a request. So if you have no internet connection, the normal JavaScript can't be loaded because it's sitting on a server. So yeah, you have the ability to access the cache, but you don't even get to that point because you never get the JavaScript file. It's still useful that you can access the cache from normal JavaScript, but I will show you a use case where this makes sense later in this module. Being able to access it from the service worker, on the other hand, makes a lot of sense because this service worker is always there. You don't need to fetch it when you visit the page. It's a background process, so it's already running even if you have no internet connection. Well, and using that cache, you got the chance of retrieving that data instead of sending the network request, which of course is exactly what you want to do if you have no internet connection. So in the end, by using the fetch event in the service worker, which of course will be the key to intercepting any requests you want to send, and the Cache API, you have a complete network proxy living in your service worker, which allows you to control if the request really is allowed to continue to the network, or if you want to return a response from the cache, if available. So with that, let's dive into using that Cache API, and let's learn how you can actually decide which assets to cache, how you cache them, and which different strategies you can use to do so.